In this video, we will see the radius of curvature in the case of Cartesian form, both the explicit and implicit form, and parametric form of the equation of a curve, then on the polar form. So in all these cases, what is the formula for radius of curvature, and then do few problems on them. Now first, curvature means it is the rate of bending of a curve in any interval, and curvature of a circle is the curvature of a circle at any point on it equals the reciprocal of its radius, and radius of curvature is in the case of any curve at any point is defined as the reciprocal of the curvature. So curvature is the rate at which the curve bends, and for a curvature of a straight line, you know that it is already 0. Curvature of a circle is the reciprocal of its radius, and radius of curvature in general is nothing but the reciprocal of the curvature. So find the curvature, find its reciprocal. So that is how radius of curvature is defined. But having derived formula, whenever we are given a curve y is equal to f of x, whether we are given in the Cartesian form explicitly the equation of the curve or implicitly like f of xy equal to 0. So in both the cases formula are given, and then parametric form like x is equal to f of t, y is equal to g of t. So when you are given that, then what is the formula for the radius of curvature, and then the polar form r is equal to f of theta. So in all these cases, what are the formula? So they are listed here. In the case of y is equal to f of x, it is you find the first derivative. In some books you will see that the first derivative, that is dy by dx, when you are given y is equal to f of x, Jacobians we have already finished, and in radius of curvature 2, with regard to the Cartesian form, whether it is given as y is equal to f of x or the implicit form f of xy equal to 0, or in the parametric form x is equal to f of t or y is equal to say some g of t. So we had already dealt all this, which are given by the formula which is written here in first subdivision, and the second and the fourth one. And in the case of y1, if it is infinite also, then which formula is to be written? So that also we have already discussed, and the problem under that also we have done in the classroom. So now our concentration is only on the polar form of radius of curvature. That is, if I am given r is equal to f of theta, that is r is a function of theta, then how are we going to obtain the radius of curvature? So that comes under polar form of radius of curvature.
Now in the case when
just to recollect what we have already done in the following few slides, we have recalled
in that case
how to
what
find
we have to have is
the Cartesian form of radius of curvature when you are given y is equal to f of x, and when you are given the implicit form f of xy is equal to 0, and when you are given the parametric form of equation of the given curve. So accepting the what is given in the note, rho is equal to 1 plus x1 square whole thing raised to 3 by 2 by x2. So that we have already done, and in WhatsApp you have copied the problem which comes under this category. So now in this we will just concentrate on the third one. So you can just go through the following few slides based on the formula given in 1, 3, 1, 2 and 4. So the third one only we are going to discuss now.
Then you are having y as a function of x. So explicitly you have this is the explicit form. But when you have say something like this, x square plus y square plus 2gx plus 2fy plus c equals 0. This is also in Cartesian form only, but you cannot write y as a function of x. So that is not possible. So in such cases we call that as implicit function. So in this case, what should be the formula? So this is the formula. The f suffix x stands for the partial derivative, because f is a function of both x and y. So in such cases you need to talk about partial derivative. So f suffix x stands for dou f by dou x, f suffix x stands for dou square f by dou x square, and fy stands for dou f by dou y, f suffix yy stands for dou square f by dou y square, and fxy stands for dou square f by dou x dou y. So this is the formula, fx square plus fy square whole thing raised to 3 by 2 divided by fxx into fy square minus 2 times fxy into fx fy plus fyy into fx square. And then parametric form, if that is given, like x is equal to function of t and y is function of t. For example, x is say at square, y is 2at. Then in that case, this is the parametric form of equation of parabola. You have y square is equal to 4ax to be the Cartesian form, and this is the parametric form. So in such case, what is the formula to be used? So depending on the problem, so first check the problem whether it is it comes under Cartesian form, and there too it is whether it is explicitly given or implicit function is given. Then accordingly you have to choose the formula. And then second one is you have the parametric form. So in the parametric form, again sometimes it may involve t, or sometimes it may involve theta also. So in such case, what is the formula to be used? This is the formula to be used. In the first case, if it is explicit, use this. If it is implicit, you have to use this. And then for parametric we have this. And then for polar form, that is polar form means you have r is equal to f of theta. R is equal to f of theta. So in such case, this is the formula. So here r dot stands for, you have r to be a function, so it is dou r by dou theta, and r double dot stands for dou square r by dou theta square. So this is the formula. R square, formula is r square plus r dot square whole thing raised to 3 by 2 and divided by r square plus 2 times r dot square minus r into r double dot. Now here you are given the curve and the corresponding parametric form. So these types of problems, that is finding the radius of curvature in the case of parametric form, is already discussed in the classroom. So few more of the same kind for you to practice as given here. Parabola, this is the parametric form, and for ellipse this, and hyperbola this, and in the case of rectangular hyperbola you have this, and for this curve you have x is equal to a cos cube theta, y is equal to a sin cube theta. So these are to practice the Cartesian form, the parametric form of equation is given, then make use of the corresponding radius of curvature formula, and then you can derive the you can find the radius of curvature. Now in the case of Cartesian form, we have very few problems illustrated here. This is the formula, rho is equal to 1 plus y1 square to the power 3 by 2 by y2. Find the radius of curvature at any point on the curve y is equal to a log secant x by a. So first write down the formula. Now you see that it is y is equal to function of x. Cartesian form is given. So accordingly, the Cartesian form of ROC is to be used. So this is the formula. Consider your y, this is a log secant of x by a. You are differentiating this with respect to x. So log of something is 1 by that, and then function of function rule is to be used. When you differentiate secant x by a, you have secant x by a into tan x by a, and then again function of function rule. So 1 by a into 1 by a. So you can cancel this secant x by a and this, and you are left with a can also be cancelled. You are left with this. Now again for y2 we need so y2 you'll have to again differentiate with respect to x. So you get tan on differentiation gives you secant square, and then function of function rule, so you have 1 by a. Now you substitute these values in this formula. So rho is equal to 1 plus tan square x by a whole thing raised to 3 by 2, and in the denominator y2 needs to be substituted. So you have this, and this 1 plus tan square is secant square, so you have this. So you have in the numerator this one will go up, so a into secant x cube x by a, then the denominator secant square x by a, so 1 secant square can be cancelled, so you are left with this. So in this case the radius of curvature is given by a into secant of x by a. Again in the same Cartesian form we have another problem. You are asked to find the radius of curvature of this curve y is equal to f of x, Cartesian form explicitly given. So this formula is to be used. Write down the formula first, and then consider this y, differentiate that with respect to x first. So this hyperbolic on differentiation gives you c into hyperbolic sine x by c, function of function rule, 1 by c you have, cancel out c, you have this hyperbolic sine x by c, and then again you are differentiating that. So hyperbolic sine on differentiation gives you hyperbolic sine of x by c, function of function rule, so 1 by c. Now substitute these values in this. So you have 1 plus hyperbolic sine square x by c whole thing raised to 3 by 2 divided by 1 by c hyperbolic cos x by c. This c goes up, and 1 plus hyperbolic sine square is hyperbolic cos square x by c raised to the power 3 by 2, and this is what you have. Cancel out 1 2 and this half, so you have hyperbolic cos square x by c. Because we are cancelling, see in the numerator you have hyperbolic cos cube, here hyperbolic cos, so cancelling one hyperbolic cos, you have this, and you can further have it, because if you are asked to show something, show that rho is equal to y square by c, something like that, then further simplification needs to be done. Otherwise it can be stopped at this stage. Now one more problem, find the radius of curvature at a point is given. In the previous cases points were not given, so here it is given on the curve. So y is equal to f of x, Cartesian form explicitly given. So we'll have to use this formula. So consider the formula. Now you have to find rho at this point. So you first consider y, what is given, then differentiate that with respect to x. You have this 2x minus 3, and again differentiate, you get y2, that is 2. Now y1 at the point 1 comma minus 1 is minus 1. You are substituting in the place of x, you have 1. So you have 1 minus 3 plus 1, so minus 1, and this one comes as such. Now substitute these values here. So you have 1 minus 1 square, so 1 plus 1 raised to the power 3 by 2, so 2 to the power 3 by 2, that is 2 into root 2 divided by 2, so you have the answer as root 2. Next, for the parametric form we will consider this problem, and this is the formula x dot square plus y dot square whole thing raised to 3 by 2 by x dot y double dot minus y dot x double dot. In some book it may be written as x prime also, that doesn't matter. Now you find the radius of curvature at any point on. So here parametric form is given, so that means this formula is to be used. So consider ax, which is this. You find the first derivative, that is with respect, you are differentiating that with respect to theta, so you get a into 1 minus cos theta, and then for this you have this is 0, so a cos theta is minus sin theta, already one minus sign is there, so a sin theta. Then you differentiate this again with respect to theta, this will be 0, so a minus sign is already there, so cos theta and differentiation gives you minus sin theta, so you have plus a sin theta, and this one again differentiating with respect to theta, that is y prime, again on differentiating with respect to theta gives you y double prime, and that is this. Now consider the formula, this one, and substitute. So we have x dot square plus y dot square whole thing raised to 3 by 2 x dot y double dot minus y dot x double dot, that is our radius of curvature in the case of parametric form. Just substitute these values, x prime square you have, and then y prime square whole thing raised to 3 by 2, and x prime is this, y double prime is this, minus you have this y prime to be a sin theta and x double prime to be a sin theta. Then multiply this so that you have a square cos square theta with the negative sign, and here minus a square sin square theta. So you have a square, this is a square cos theta, and then this one you are clubbing these two, cos square plus sin square, that gives you 1. So when you take a square out, you are left with 1 minus cos theta with the negative sign outside, so 1 minus cos theta, and the numerator you have expand this. When you expand that, what you get is this is a square into 1 plus cos square theta minus 2 cos theta plus a square we are taking out, so sin square theta whole thing raised to 3 by 2, that's in the numerator. And of course in the denominator we have already said, so we are taking a square out with the negative sign, means you will have 1 minus cos theta. So coming to the numerator again, cos square plus sin square, so you have a square into 1 plus 1 minus 2 cos theta, so 2 minus 2 cos theta, taking 2 outside, so you have 2a square into 1 minus cos theta whole thing raised to 3 by 2 divided by minus a square into 1 minus cos theta. So you can cancel 1 minus cos theta, so you have minus 2 root 2a 1 minus cos theta to the power half. So this is, in the next step we have 1 minus cos theta being 2 into sin square theta by 2, we have the next step. But rho is taken as radius of curvature, so we'll have to consider the positive value, so 4a sin theta by 2, that is the radius of curvature. Next problem, find the radius of curvature at any point t on the curve y square is equal to 4ax. So that's parabola, and in the case of parabola, so here at the point t is given, parameter is given, so which means you are supposed to use parametric form only. So the parametric form of equation of parabola are given by x is equal to at square, y is equal to 2at. You find the first derivative, x prime 2at it will be, and y prime that will be 2a, x double prime it will be 2a, and y double prime it will be just 0. So just differentiate with respect to t and you arrive at this. Consider the formula, substitute the values here. So x prime is 2at and y prime is 2a, so you have this, and this on simplification will give you this, and again row with the positive sign we consider. So ultimately we have to write this as 2a into 1 plus t square to the power 3 by 2. So this is the radius of curvature. Now for implicit form of radius of curvature, we have the formula being given by this, fx square plus fy square whole thing raised to 3 by 2 divided by fxx into fy square minus 2 times fxy fx into fy plus the product fyy fx square. So this is the problem, find the radius of curvature at the point of the curve. So here it is in Cartesian form, but implicitly it is given. So we'll have to use this formula. So implicit form of radius of curvature is this, write down that and name that as equation 1. Now you consider the given expression as f of xy. So the given expression is considered, and then you partially differentiate with respect to x and evaluate that at 0, 0. So when you differentiate this partially with respect to x, you get 3x square minus 4xy, 3y square, and then you don't have x here. Here it is 10x, here it is minus 6y, you don't have x here and here. And at the point 0, 0, so all of them contain x or y, so answer is 0. So fx evaluated at 0, 0 gives you 0. And fxx we will consider, so partially differentiating fx, this one with respect to x, so 6x minus 4y, then you don't have x here, it is 10. When evaluated at 0, 0 gives you 10. And then fy, this is f, we are differentiating partially with respect to y, so from here you get y term is here, so minus 2x square, and this on differentiation gives you 6xy minus 12y square, there is no y, so 0, and this is minus 6, and this is 14y minus 8. At 0, 0 when evaluated you get minus 8. And in the same way fyy, you have 6x minus 24y plus 14, evaluated at 0, 0 you get 14. Then partially differentiate fx with respect to y to get fxy. So here is this one, and fx you have to differentiate partially with respect to y, so you get minus 4x plus 6y minus 6, evaluated at 0, 0 gives you minus 6. Now substitute these values in 1. So this is our equation 1. Substituting these values in 1, we get this. Fx square is 0, fx is 0, and fy square, so fy is minus 8, so minus 8 square, so 64, and fxx, it is 10 into fy square, it is minus 8 the whole square, you have 64. In the next one it involves fx, so 0 you get, and here also you have fx, so 0. And then further simplify this, so you have 64 into 64 to the power half, 3 by 2 can be written as in this way, and 10 into 64 you can cancel 164, and square root of 64 you have 8 by 10, and that gives you 4 by 5. So this is the radius of curvature of this curve, which is given in the implicit form. Now we'll concentrate on polar form of radius of curvature.
we find the radius of curvature of the cardioid r is equal to a into 1 plus cos theta at any point r comma theta on it, and we also prove that rho square by r is a constant.
This rho square by
so
r
for which you first consider r is equal to a into 1 plus cos theta, then differentiate that with respect to theta, you get r1. See, either you use the formula with r1 for r dot and then r2 for r double dot or just r dot r double dot. So in this it's already type written, so this r1 stands for r dot, that is dr by d theta. So this r is equal to a into 1 plus cos theta, and differentiation gives you minus a sin theta. Then you differentiate that again, so you get minus a cos theta. So r dot is minus a sin theta, which is taken as r1, and r2 is minus a cos theta. Then consider the formula for radius of curvature, which is rho is equal to r square plus r dot square, whole thing raised to 3 by 2 by r square plus 2 r dot square minus r into r double dot. Just substitute these values. The simplification you can easily go through from this PPT, and finally you arrive at rho is equal to 4 by 3 a into cos theta by 2. Now for the second part, we will see that in the second slide.
You have this one is 1 plus 1 2.
So in the same problem we are also asked to prove that rho. So in the same problem,
so you have this, and taking 2 out, you have 1 plus cos theta, whole thing raised to 3 by 2. This a cube is there, but in the denominator, when you come to the denominator, you have 1 plus again cos square theta plus 2 cos theta, and this one will give you minus a square into cos theta plus cos square theta. And this is there 2a square sin square theta. So that is what is written here. You have 1 plus cos square theta is there, 2 cos theta is there, and then a square is taken out. So 2 sin square theta is there, and here cos theta plus sin square theta. Here already one minus sign is there, and here also minus, so you get plus sign. So cos theta and then cos square theta. So you have when you consider this and cos square theta, 2 times cos square theta, you have here 2 times sin square theta. So they together gives you 3. And then 2 cos theta, so those two together gives you 3 cos theta. So when you take 3 out, you are left with this. So 3 into 1 plus cos theta in the denominator. Numerator, you have already 2 into 1 plus cos theta. So here it is a cube, here it is a square, just get a. And this you can rewrite as 2 root 2, this a is written as such, and 1 plus cos theta, 3 by 2 is 1 plus half. So you have this, and 1 plus cos theta, you have the formula 2 cos square theta by 2. So you have 4 by 3 a. From here you are getting 2. So root 2, that gives you 2. So 4 times a. The denominator, the 3 is written as such, cos square theta to the power half, so cos theta by 2. So rho is your 4 by 3 a into cos theta by 2. But in the second part, you are asked to show the rho square by r is constant. So we shall consider this rho.
So in the same problem, we are also asked to prove that rho square by r is a constant. Already in the previous slide, we had rho to be 4 by 3 a into cos theta by 2. Then we will have to prove that rho square by r is a constant. So for which we square this, and this is what we get. And we know that 1 plus cos theta is 2 times cos square theta by 2. Therefore, cos square theta by 2 is half into 1 plus cos theta. So that is replaced. And why it is replaced like this? Because we are given r as a into 1 plus cos theta, and here 1 plus cos theta comes, so that can be replaced by r by a. So it's only for that purpose we are converting. Rho square is found, and then we make use of the given equation of the curve to arrive at this. So from this we see that rho square by r is 8a by 9, which is obviously a constant because a is a constant.
Replace 1 plus cos theta by r by a.
So here is another problem to find
the rho square by r cross multiplying 8a by 9. A is a constant, so you get rho square by r to be a constant.
So here is another problem to find the radius of curvature when you are given the polar form.
Show that for the curve r bar n equal to a bar n cos n theta, the radius of curvature is
you are given r bar n equal to a bar n cos n theta to be the curve,
the polar
and
form.
you have to show that the radius of curvature is a bar n divided by n plus 1 into r power n minus 1.
Now if we directly differentiate
various
values, so we take logarithm on both sides.
R bar n is equal to a bar n cos n theta,
point to be
for which
noted
how
here
we
to
obtain
have
our rho. Then for various values of
in a simple way,
how we can
it is
obtain
better
rho
you
can
take
be easily
logarithm
determined.
on
In
both
fact,
sides
that is
and
discussed
then
in
proceed
the
further.
next
So
slide,
when you take
so that
log
you
on
can
both
easily
sides, you
go
get
through.
n log
We will
r
have only
plus
this
n
one
log
first.
a mean equal
You
to
are
n
given
log a
r bar
plus
n is
log
equal
of
to a bar n cos n theta. Then we
is
take
log a
logarithm
plus
on
log
both
b.
sides because directly doing the problem will be somewhat
So that
tedious.
is,
So in this
used
case,
here.
it has to be
And,
remembered
so
that we'll
logarithm
have
of
to
cos
take
and theta.
the
We are differentiating with
logarithm
respect to
on
theta,
both sides,
so
so
you
that
have
we can easily
n
obtain
by
r
r,
dot and r double dot. That is
this
r1
one, n
and
by r,
r2.
log r
So
and
when
differentiation
you
gives you
take
1 by
logarithm,
r,
it
and
is
then
n
that
log
has to
r
be
is equal to
differentiated, so
n
that
into
gives
log
you
a
dr by
plus
dt.
logarithm of cos
And
n
n
theta.
is there already, so n by r into
Because you
dr
know
by
that
dt,
log of a
here
plus
it is
b,
independent
I mean
of
log
r,
of
so you get
ab is
0,
log a plus
and
log
this
b.
one
That's
independent
used
of
here.
theta, so you get 0.
Now you
and
differentiate this
one,
with respect to theta,
again
you get
same
n by r.
log x
Log
in
r and
general.
differentiation gives you 1
1
by
by
r.
x.
With respect to theta, you are
When you have
differentiating,
this to
so
be,
dr by d theta.
I mean this has to
And
be
n
differentiated,
log a
that
it
gives
is
you
independent
1.
of theta.
So you have
So you
that
get 0.
sin and theta,
And this one log
this
x
has
on
to be
differentiation
differentiated, that
gives
gives
you
you n.
1 by x.
So n
So
into sin
here
and theta
1 by
by
cos and theta,
which is
and then a function
tan
of
and
function
theta.
rule. So
And
when we
this
differentiate
r,
cos and theta,
you
you
can
get
cancel
minus
out n.
sin and theta into
So
n.
this
So
r
that
goes
is
to
what
the
is
other
written
side.
here.
So r1
So
is
this
equal to minus
simplification
r
gives
tan
you
and theta.
r1 to be minus
Next we
r,
find
n can be
r2,
cancelled, and you are
remember
left with
here
minus
this is a
r
function
tan
of
and
theta.
theta.
This is also a function
Now
of
if
theta.
r1 is
So
this, that is
product
dr by
rule is
d
to be
theta is this,
applied.
differentiating this once more, we get
So you have
this one. That
differentiating
is,
this with respect to theta
you
again,
have
we
r
obtain,
and theta. So
you
product
are
rule is to be
retaining this
applied.
r as such.
So first
when you
we will
differentiate
differentiate
to get secant square
tan.
and theta.
So you get
And then
secant square
retain
and
this
theta
as
into
such
n.
and differentiate that.
Function of
That
function
gives you
rule.
dr
Minus
by
sign is
theta.
kept as such.
So
outside.
nr secant
And
square
then
and theta
tan and
retain
theta
as
you
such,
have, and
you are
r
substituting
when you differentiate with respect to
dr
theta,
by
you get
d
dr
theta
by d theta.
As minus
And
r
you
tan
substitute
theta.
dr by d theta value as
tan and
minus
theta
r
is
tan
there, so you
theta,
get
tan
minus
and theta
r
from
tan
the
square
previous step.
and theta.
So you get the next one.
So
And you take this minus sign inside, so you get r into tan square and theta minus
secant
nr
square and theta
secant square and
r
theta.
into tan
Now
square and
polar
theta.
form of
Taking
rho is
r
used here.
outside,
Just
we
substitute
have,
the values, and on
tan
simplification.
square n theta.
Now carefully simplify this. You will be using that 1 plus tan square secant square, all that you will be
taking
using.
this minus
So
inside.
so using that and on simplification we get this. Now cos and theta is replaced by r bar n by a bar n because we are given the problem r bar n equal to a bar n cos and theta.
Formula.
So rho ultimately you get like this.
Just substitute
For various
and,
values of n, what is this rho? That is given in the
formula
next
that
slide.
1 plus tan square is secant square theta. You get this, and so just simplify this. You get these values: 1 plus 2 tan square theta, 2 tan square n theta minus tan square n theta from here, and r square is taken out. That's why we have all this, and we have 2 tan square minus, so just tan square, and secant square 1 plus tan square is secant square. So this with this gives you 1 plus tan square n theta. but 1 plus tan square is secant square, and already here also you have this, so with n, so n plus 1 secant square n theta, and 1 secant square can be cancelled, so you have 1 secant square can be cancelled, so you have r by n plus 1 secant n theta in the numerator, secant n theta in the numerator, so which means you can have it in the denominator as cos n theta. So you have this step because of that, r by n plus 1. But because we are asked to show the radius of curvature in this, further simplification needs to be done. So from the given equation, r power n is a power n cos n theta, therefore cos n theta is r power n by a power n. So that is substituted here, and this one goes up, and 1 r can be cancelled, so you have a power n rho to be a power n by n plus 1 into r power n minus 1. And this is an important formula, because see, instead of this you may be given n to be say 2, again for which the same concept is to be used. Whatever you have to take first log and then differentiate, use the formula, simplification is to be done in this way. And because we are asked to show this, further simplification is done in this way. Now on the particular case, we know that rho is given by this. When n equals 2, what happens? When n equals minus 2, when n equal to half, then n equal to minus half, these are particular cases. So correspondingly, what is that you get? The curve they are named accordingly, it will be a rectangular hyperbola. So you have r power n is equal to a power n cos n theta, r power n is equal to a power n cos n theta. So when n takes these values, n equal to 2, then the corresponding curve is called. When n equals minus 2, what is the corresponding curve called? So all that they are given here, and correspondingly the rho values can be obtained using this that can be obtained. And
so we can have these problems as homework. We are asked to find the radius of curvature, which has got two subdivisions at the point theta equal to pi by 2. So answer is given. Make use of the formula for radius of curvature in the case of polar coordinates, that is r is equal to f of theta. Polar form is given means we know the formula, apply the formula, and then get the answer. At the point theta equal to pi by 2, you need to find. See, the 4 problems what we have discussed in this, the polar form of radius of curvature, all are